the lecture is called In Pursuit of Novel Form. It's also a seminar I'm teaching right now at Harvard GSD with my students. And this is these are the two quotes that we kind of started with as a kind of introduction. The first one is by Mies van der Rohe. It's, I do not oppose form, but only form as a goal. The second is by Zaha Hadid. It is insufficient for architecture today to directly implement an existing building typology. It instead requires architects to carefully examine the whole area with new interventions and programmatic typologies. I think those two quotes are quite important. The first one, obviously, is by me saying, you know, it's not just about form, it's also about other parameters. I think that's something that is quite important in my work as well. I mean, I do appreciate form, but there has to be more to it at any time. And I think Zaha's quote is important because it's starting to question basically the kind of paradigms we have seen in modernism that are still continuously with us. And she's kind of asking to kind of look a bit deeper and actually also try to maybe look at other disciplines, try to maybe go outside the boundaries of our familiar setup and really see if that kind of can create some sort of new typology, new architecture, and so on. So this is just a quick summary about form itself. The agency of form is an essential part of our design disciplines and can be traced back with all its characteristics throughout the history of architecture. Form has traditionally served towards aspects of performance, ornamentation, symbolism, economics, materiality, and many other intentions. However, from classical geometrical configurations to elaborate Baroque embellishments, from sleek modernist assemblages to current new postmodernism and post-digital design agendas, the agency of form has always created a polemic episode, the pursuit of novel form. So what should this exploration of form look like today? Should we borrow ideas from the past and repackage them, or should we use new technologies and techniques to project into the future? Basically, what I'm trying to say is that as architects, as designers, it's almost like we want to find new things all the time. It's almost like every design has to be quite unique, and everyone is trying to be different than someone else. Hence the pursuit of novel form that we can see probably in many architects' work and in many design work. And then, of course, how do we create a novel form? How do we go about it? Do we go back to the past? Do we get inspired by history, by precedents and these things? Or do we take advantage of what's around us at the moment, new technologies, other disciplines that we can look at, collaborate with, and so on? And also the techniques that we have available. For this lecture, I was thinking it would be interesting to look into one specific technique, which I call the gradient technique. It's a clear distinction towards what we are familiar with, which is the kind of the modernist paradigm, the domino diagram, which basically is the idea of repeating things, of stacking things, of let's say principles like symmetry and some other characteristics. Where if you look at gradients, it has a totally different kind of organizational system. It provides many more opportunities. So I was trying to, for this lecture, actually categorize all my work as gradient work. And if we look at gradients, historically gradients have been established or have been an established instrument within the architectural discipline. So it's been around and used in conjunction with surfaces, facades, and planar geometries. However, gradients have now developed from a decorative two-dimensional pixel pattern tool to a performative and spatial, more like volumetric application with the potential to produce architectural typology. Given our contemporary technologies, some of the most valuable gradients are currently based on generative volumes and performative surfaces. These new kind of gradients do not simply rely anymore on variable parameters such as geometry, density, type, color, background, etc., and its organization, but can now also include performative and programmatic aspects. Gradients produce emergent characteristics and can be defined as a transitional sequence between two or more, mainly more, inputs. All parameters of these inputs, such as A, B, C, and so on, are interchangeable and hence result as a vast amount of options. Within this zone of gradients, we encounter properties of emergence, variation, transition, reorder, relationships, and syntheses. I would argue all qualities that we might not necessarily find immediately in modernist principles or in postmodernist principles. The systematic approach to produce emergent effects relies on three main geometric gradient organizations, which are called directional, compositional, and central, which determine a specific geometrical relationship. The output of gradients ranges from organization principles, material applications, structural integrity, visual effect, to a rereading of typology itself. The projects shown here in this lecture investigate the use of pixel, pattern, and volumetric gradients as an application to speculate on novel form and typology. Maybe let's go back. I think on the right, those are the kind of three main chapters that I have in mind. Pixel gradients, in the center you have pattern gradients, and then on the right you have volumetric gradients. And then if you think about the kind of organization that they have in mind or that they share, one is more directional, one is more compositional, and one is more central. And I'm going to talk about those criteria now here. So pixel. The idea of gradient in painting was influential in the Renaissance period. Sfumato is one of the four canonical painting modes of the Renaissance, which implements gradient as a technique. The other three techniques being cangiante, chiaroscuro, and unione, which means basically outline. Paintings such as the Mona Lisa, shown in this picture here, exhibit the pixel-based sfumato techniques in its full spectrum. Da Vinci describes sfumato as without lines or borders in the manner of smoke or beyond the focus plane. And if you look closely at the image, you see that basically the color is kind of smeared from one side to the other. There's no clear boundary. And it's this kind of gradient technique that makes this painting quite interesting and unique. The second is pattern. And pattern gradients have had their rise in the 20th century and used generally in popular are used generally in popular culture, such as advertising, fashion, etc. We see it very much all the time in any kind of contemporary graphic and so on. The influence of this graphic strategy can be traced back to the movements of Cubism, Futurism, but was mainly used in op art, derived from applications of the Bauhaus. Op artists used abstract gradients to play with illusions of the spectator and to introduce three-dimensionality onto two-dimensional surfaces. And I think this image is actually quite intriguing by Escher, where you see the horseman obviously going from one side to the other, left to right. You have a figure ground going on at the same time. So this kind of pattern gradient is actually quite intriguing here. And then the third category is volume. This is something that's actually quite, I don't want to say new, but it came about with like animation and basically Pixar and Disney and these guys. And since the evolution of digital technology, computer graphics have used volumetric gradients to animate objects, environments, and characters. In contrast to pixel and pattern gradients, the volumetric gradient has parametric qualities, which basically means that if something changes, something else changes as well. The flux from one volumetric state to another is orchestrated by the simultaneous and coordinated movement of surfaces, points, and vectors, and allows for continuous volumetric massing change. So those were the three kind of gradient chapters, and now we have the kind of organization of how those gradients work. The first one is directional. Directional organizations have start and end points, but can include additional inputs within its orientation. The study specifies directional gradients within a Euclidean boundary and non-boundary condition. And if you look closely, these two kind of examples start on the left with a very basic square and transition to kind of other shapes. And if I would change one of those shapes in between, this whole thing would update immediately. The second compositional or organization system is compositional. The compositional organization implies the play between multi-directional and omni-component gradients. Due to its rich and variable inputs, it offers potential to produce exceptional complexity within its investigation. And these examples basically show a series of rectangles which are connected to each other. And every time we basically change a few parameters such as the line weight, the line color, or the line type, and constantly changes its kind of effect. And then the third organization, and there might be more at the end of the day, but those are the three that we are showing here, is the central organization. A central organization is based around a joint midpoint for all input data. The effects produced are a reading of new geometries within the overlapping qualities and merging operations. And again, if you look at the diagrams at the bottom, you see it starts with a rectangle, and within the center point, there's a deformation of that rectangle and the kind of transition between one shape to the other as well. So that's the kind of, I would say, conceptual layout that I try to organize these projects a little bit. And I'm going to start first with ideas that are related to pixel, and in this case also directional gradients. And there's actually an entire series of projects that I've been doing in the last few years. This picture is of a project we just did in Denver, which is actually still under construction. This is just one part that's been installed. But the Pixel series is a set of physical installations which specifically engage with architectural typologies / elements, such as the corner, the facade, the parapet, the atrium, and the lobby. It can be many others, but those are the ones that we have implemented so far. Composed out of hundreds of unique and individual elements, the pixel compositions form an abstract landscape of geometries which perform several tasks. They act as an ornament to the building, they communicate between the audience and its architectural context, and they play magic tricks by producing these kind of op art-like effects. So the first project is the Durango Project. It occupies the concert hall on the Fort Lewis campus in Durango, Colorado, and is located on the southern edge of the building, which is an opera house. Wrapping around two brick facades, the installation partly eliminates the corner and parapet of the concert hall, introducing an alternative tectonic solution to the building volume. I also tried to give each of these projects a kind of a problem name. In this case, it's the corner problem, because what this project does, it kind of starts to dissolve the corner, which I think is quite an interesting chapter in architecture or problem in architecture to kind of look at. Because you have the series of kind of pixels that start to wrap around both facades, and of course they have to wrap around the corner as well. And what it really does, it starts to soften the edge. It kind of makes the edge disappear. And especially doing different kind of conditions of the day, you get different light effects, shadows, which kind of either enhance this effect even more of eliminating the corner, or make the corner disappear in total. So these are just a few images on campus. What's maybe interesting is that this is a so-called public art project that was initially designed to go on the other side of the building, to welcome all the guests entering campus, particularly potentially new students, and advertising the school. But at the end of the day, the students asked if we can rather project this towards the campus so the students could see it every day and not necessarily guests that come maybe once or twice a year. So we managed to kind of flip this whole thing onto the other side of the building. The second project, again within this Pixel series, is called the problem of horizontal extrusion. It's located within an 3-story atrium in Salt Lake City at the community college. And basically, the project connects all building floors, both physically and visually, through elements of vertical extrusion. The continuous formation offers the possibility for the installation to be seen on every level in a different way, while continuously creating new experiences and modes of engagements for the viewer. The shift in color occurs on a horizontal level, while the shift in the materialized elements, such as the folds that it occurs, are more vertically. So here's a few images of basically this thing. When you stand at the bottom and you look up, this is the kind of view you get. Also, what's quite intriguing for us was this kind of idea that on each level you have a different experience of this piece. So you almost read it as a chapter rather than in its totality. And there were also a few kind of parameters we had to engage with, which was distance to the viewer, kind of structural capacities, how much weight can this thing take, can the wall take. But at the same time, it's also about budget, how much money can we spend on material. So this is something that was basically all included in our design, where we had to not just design it based on kind of visual, but also about its logistics in terms of weight, material, and so on. The third Pixel project is situated on the interior north facade of the U.S. Cellular Center at the entrance lobby in Cedar Rapids in Iowa. Initially conceived as a decorative and purely decorative ornament, that's what they asked for. It kind of turned into a large installation that's more like a focus point now, directing the audience towards the entrance of the auditorium, while performing as an informal gathering or congregation point and temporary event location. So what happened basically is that the client asked for something and the project kind of took on its own life. So you have these kind of events happening when there's a band playing, for instance, or when they have kind of small booths set up, when they're selling certain things or promoting certain things. It all happens now at this location, as this kind of point of congregation. And the interesting part really is also, and these are things you cannot simulate necessarily with the computer, is that we specified a series of colors. I think it was 6. But because of the kind of reflection and the material surface texture, the kind of semi-glossy paint that we had, it turns out that there's actually many more colors. So when you go in with your pixel picker in Photoshop, you get more than 6, 7 colors. You get almost like 15, 16 different shades. And that's actually quite interesting to us because these are things that we didn't anticipate necessarily when we designed it and when we put it up, and so on. The final kind of project for this series is a competition I did with the Very Many in New York. It's for an opera house in Korea, in Busan. And I would say I would call it the roof problem. And maybe we start with this slide because it kind of shows on the top left corner the silhouette of our proposal, which is the number 1 top left, which has this very kind of intricate roof. And you see the kind of contour, the outline of other, or silhouettes of other kind of important opera houses in the world. You have the Sydney Opera House, which is very iconic, the Walt Disney Concert Hall, and then also the Berlin Philharmonie. So for us, the kind of silhouette was something we tried to really embrace here and also make it somewhat distinct and novel based on its kind of neighbors. But also because the roof is really important. This is kind of located on this what was supposed to be a new island, and which is surrounded by skyscrapers. So the view onto this would mainly be also from the top. So you actually have to design the roof. We decided very quickly that we're going to stick with the kind of boundary of the site, which was more like a circle. And the program was actually quite complex, but if you break it down into very basic components such as public-private, you're actually able to navigate much faster, much more coherent. So we basically put everything that's private into the center as a kind of core, and everything that is public, we put it on the perimeter of the circle. And it's a 3-story building. And it has all the kind of logistics at the bottom and all the kind of public spaces on the first floor. And basically it has 3 main auditoriums, which was required as a kind of programmatic element. But I think here you see in the plans very well the kind of the spine on the left, which is the kind of back of house, which occupies quite a lot of the floor plan. And then on the right side you see the kind of public space, which is all the kind of the foyer area and the kind of informal gathering area on the perimeter of the plan, and then the kind of where the changing rooms are, and the kind of things where the staff goes are more like in the center, and then you have these kind of auditoriums plugged into that core. And again, the facades here was mainly the roof. And it has this kind of pixelated quality that we're interested in. And these pixels, again, are not just surfaces, but they're also performative in a way, because basically they turn into chimneys, which take on a few kind of performances, such as, ventilating air, for instance. You probably all heard of the chimney effect, which is incorporated here. You can bring in natural light. You can actually direct the light. And we also have a roof garden at the top, which also is something that you would then start to experience that roof, the kind of the pixelated extrusion roof, also architecturally. And this is just an image of that kind of view from the roof garden. The second chapter is pattern, or compositional gradients. And I was supposed to write a text this morning, but I got stuck at the Yeshiva Museum, so there's no text for this. But the idea here really is connecting shapes. And this is something I tested on a house, or actually 2 houses, which I'm going to show. And the modern house, we call it the problem of the modern house. The modern house usually is also something that we see very often as a kind of extrusion, maybe as an aggregation. And we looked at all these kind of typologies that you see here and started to really understand how they work. And one idea was really to look into the qualities of maybe those typologies and extract information, such as the kind of silhouettes of them. Like you see on those diagrams, you have the kind of the single gable house, you have the kind of double vault, you have a kind of a church, and we take those silhouettes and connect them somehow and actually see what happens, right? And see if you can turn it into basically a house that's not necessarily designed in plan or section, but that's designed through this kind of gradient condition of connecting several things to each other. House was proposed in Venice, in Los Angeles, right at one of those canals. It also is actually not a large house; it only has a couple of bedrooms. But these are the kind of effects you get in terms of section, in terms of the way it meets the ground, and these things. But this house, even though it had a certain kind of interest, didn't really produce the kind of effects that we wanted in terms of the kind of, let's say, internal qualities. So we don't call it a failure necessarily, but it wasn't necessarily something that we wanted to achieve. So the problem of another house comes into play, where we tried this again on a totally different site. A little bit different program, but basically with the same technique. We basically exchange now the silhouettes into a pyramid, an arc, and this kind of what we call a camelback housing typology, which you also find in the south very often. And we tried this for a little bit. This was also a little bit better because we also weren't just stuffing, as I call it, turkey with program, but we also started to understand the kind of organizational lines that are actually in the geometry. So we take advantage of using those as walls, as kind of organizational systems for staircases, and to position program and to actually cut into the building and so on. So this house, you see here, some of the walls actually following also the curvature or are parallel to some of the exterior walls. So this house is something that we consider a little bit more successful because it's more true to its initial, let's say, diagram that we had in mind. And it still produces kind of a series of variation of spaces. So you have here, for instance, the outdoor terrace on the top floor. You have here this kind of very strange triangular space. You have a very generous kind of double height space for the living room and so on. So there were moments that were of interest for us that we can now take and as a kind of success and actually implement it maybe somewhere else. But for me, these kind of projects are also like a little bit like concept cars. When you look at concept cars in the automobile industry, they don't necessarily get developed into a car that gets built. But what happens sometimes is that you take the good things of a concept car and you take that and maybe build it. So some of these projects are definitely in that kind of realm. This is a project now for a building in Texas Tech. They asked us to design a kind of a pavilion for their kind of center space of that U-shaped building. The pavilion always was interesting to me because it never had a function except maybe just hosting people or giving shade. So we tried to actually implement a bit of function into it. So we introduced kind of 3 programmatic islands. One is more like a gateway where you can actually walk through. It guides you into the kind of entrance area of the courtyard. It also has these informal benches on either side, so you can sit down and rest and actually have a conversation with somebody. The second one was kind of a mini auditorium that faces also the cafe area, so you have maybe the opportunity to introduce, let's say, little kind of lectures or music events and these things. And the third one was a small kind of classroom for students to actually sit outside and have an informal class with a teacher, or maybe just sit there as a group and communicate about any kind of topic that they're interested in. So the idea that these 3 islands have 3 different programs really helped us to design this a bit more and think about a pavilion that now has a bit more of an interest in terms of a program rather than being this kind of folly as we've seen it many times. And I've also done a couple of pavilions that have no other program except just being there necessarily. But this is something that we try to really implement and combine with the programmatic aspect as well. The final kind of project for this chapter is the problem of a procession, which is a bridge. This is a pedestrian bridge that we just got approved to build in Fort Worth, Texas. So we're basically building it now as we speak. It's 62 feet long and based on a Catenary curve stress diagram. It's composed of unique cross-laminated timber panels, which are connected through lamination, so they're glued to each other. And around the center of the bridge, the path kind of splits. It kind of gets wider, highlighting the community seating elements for the public to briefly rest, rejoice, enjoy views of the creek, and engage with its surrounding landscape. So you see here the benches, and these are things that I think are important to provide in any kind of public setup, that you have moments where you can actually sit down, rest, maybe have a conversation with someone else, even if it's a stranger. And the other option was really that it's a material that's timber that we haven't really used much in the past. So there was a lot of learning in this kind of project. And we did material testing with our engineers. We had to actually test how far the glue goes when it breaks, how far you can actually push the material. But again, you see here the kind of sections of the bridge, which are pretty much all different. So they're all pretty unique and different, and they all kind of change. And maybe what's also interesting is all the important components are embedded in the design. So the handrail is embedded, the seating is embedded, even the kind of slip surface is engraved. So the entire bridge is basically made out of timber, and that's it. Another feature is that we're building this thing in Austin. Texas, which is only 2 hours south. And we're basically going to put on a large truck, a U-Haul oversized truck, so that the bridge was also designed to fit on it. So there's a certain kind of size and dimension that we had to keep in mind, including weight as well. And this is just a diagram showing that it basically will be plugged and played into its position once it's built. Okay, so the last chapter is volume, particularly looking at central gradients. And volume is a collection of projects promoting programmatic and visual production within the built environment. Architecture is a cultural practice. It is obliged to create opportunities for its constituencies to grow and engage with each other. Community spaces and public domain are important cultural catalysts of our society and need to be upgraded with architectural design concepts which are engaging, functional, and allow for multi-purpose use. The first project of this volume series is a bench, the problem of a bench. So we wanted to rethink the bench paradigm by creating a loop bench instead of a kind of linear bench. This continuous looping configuration allows occupying the bench in new ways while breaking with its formal traditions, hierarchy, and linear organization. The bench redirects its occupants or strangers to face each other, hence offering new processes of urban communication. The bench was also made out of recycled plastic bottles and recycled plastic bags, as you can see here. So again, the idea was really to kind of take away the notion of a linear bench where you sit and you just look in one direction. You might not communicate with the person next to you, but actually then loop it onto itself and see what it kind of produces in terms of occupation and how people engage with it. And what turns out is actually that you have to look at each other. And that for us is interesting because that also means that you have to talk to each other. And these are just the kind of the easiest way of starting to communicate. And communication to me is also key to kind of produce ideas, kind of look into culture and these things. So this is what this bench does. It also performs in a way that it lands where it has to land. So structurally, it actually goes down when it has to go down. It provides this kind of leaning element at the back. It goes also a little bit down so you can actually walk into the kind of interior of the bench. So the form also performs in that way to kind of make people engage with it and also be somewhat ergonomic as well. Another project, the problem of the elevation. This is a project that's located in Denver at a new building for UC Denver. And it's a very prominent atrium because it's facing Spear Boulevard, which is one of the main boulevards in Denver. And it's also facing downtown Denver. So it has quite an interesting kind of projection. The piece is basically mounted to the auditorium wall, but also partly suspended in space, kind of creating this kind of hybrid structure. And the initial formal logic of this project consists of basic ellipses, which then get repeated and connected and create this kind of labyrinthic, let's say, maze. But again, the idea is that you start with one simple piece, and then within this kind of, let's say, central organization, you start to kind of repeat it, rotate it, and connect it, and so on. The piece was made out of aluminum, so it's very lightweight. It's also very thin material, so it's only 0.05 thickness, which is a little bit thicker than a Coke can. We also had to introduce, because it's so thin, we also had to introduce this kind of curvature as well, because the curvature, what it does, it also helps to make it more structural. And we also, because the prominent location, were interested to kind of have an understanding how people would view it. If you're on a bicycle, if you're a pedestrian, if you're in a car, if you're in a bus, there's different kind of elevations of viewing, but there's also kind of speeds of viewing of the piece as well. So that's why we had to also think about color. So we want to introduce maybe color that has a high contrast, so blacks and whites, for instance, because we wanted to kind of keep that the simplicity out of it, because the geometry itself is already so complex that we wanted the kind of coloration of it be less, let's say, complex. So this is just a view when you would drive by on Spear Boulevard at night. Another project that is very similar, kind of in the same family as the previous one. It's installed within the main atrium space of the math department at Fenton Hall at the University of Oregon in Eugene. And the installation was envisioned as a growing network that visually and spatially connects all levels of the atrium, because there's several floors. And its adjacent staircase, which basically wraps around while producing a series of visual effects such as shadows, glow, and these things. And again, this is a kind of a volumetric approach where we started with a very basic shape, and that shape by itself got deformed within this kind of directional or kind of center orientation. And these are just a few images. The building itself is a very historic building, so it has these kind of architectural elements that are kind of in contrast to the piece that we put into place, because our place is very organic, has a lot of curvature, is also built in a way as the same way as airplanes are built, with kind of rivets and aluminum. And one aspect that was important was also the weight of this, because we couldn't really hang a lot of weight on the ceiling. I think we had a max of 200 pounds available. So this piece, even though it's about 16 feet tall, which is probably a bit higher than this wall, it only weighs 80 pounds, so it's quite lightweight again, because it's a very thin aluminum. Which brings me to the final project. This is the problem of variation. The project is located at the Fort Lauderdale Airport. It was just installed this summer, and it's fabricated out of polyurethane-coated medite. Medite is a type of MDF. Except that medite has a fire rating, which was required in the building because this is a new construction and it required the highest fire rating, so I had to use this material. The project consists of 4 main structures that are kind of assembled, and the design is assembled like a large 3-dimensional puzzle, forming soft and dynamic volumes. The abstract shapes are initial variations of each other, so they're all derived from a circle. Distributed throughout the space, they are assembled, forming several opportunities for play and engagement. So basically the brief was to create a playground for children that want to kind of waste or spend time at the airport waiting for the airplane, or actually when you land. So the idea was really to take these kind of circles and make variations of them, and really have them repeat and grow and so on. So here you see the kind of oval layout of this thing. The floor is made out of recycled rubber. We had to get this playground inspected by a Parks and Recreation officer, because you have to follow certain regulations. And the pieces, as I said, are made of medite. What you don't see necessarily here, because they're so volumetric, is that there's over 10,000 pieces in these shapes, simply because it was put together with flat CNC cut medite material, which was then painted and lacquered and these things. So here's a few pictures that we just got actually last week. We asked a photographer to go in and take pictures of some of the kids that are playing there. So these are the kind of views, this kind of overlap of circles, or kind of new circles, or kind of variations of the circle on top of each other. So you get this kind of layering. You can occupy them, you can go into them, you can jump on them. Material is very durable because it has this kind of automotive paint that is kind of a special lacquer that is really, you can't really do anything to it. So it can take a lot of beating and climbing and these things. I think this concludes the talk. So thank you again for coming. And if there's any questions, I'm happy to kind of talk through it. Thank you.
Thank you so much for coming. Thank you for the lecture. I'm very sorry about the turnout. as we usually don't schedule lectures this late in the semester, so we had to move some dates, and unfortunately we had to push you to this very late date, so it's a shame. It's interesting to see the work, and I'm wondering some of the pieces, there's actually, you talk a lot about form, but there's also the aspect of manufacturing in this, and you didn't talk that much about the manufacturing process, which I think is as interesting as the form. And also I'm wondering how much of a role the manufacturing process plays within the design of the pieces. Because it's almost like the presentation you showed, like the final piece in its environment, but not really the fabrication process, and I would be really interested in actually always see all the messy photos.
Yeah.
And
no, it's a good point, because I used to actually talk mainly only about fabrication for many years, and this is probably the first time I don't talk about fabrication. For several reasons. One, I think because I've done it now so often that I kind of wanted to see where else the work goes in terms of how to position it conceptually. But I could have given another completely different talk and shown a whole other set of slides that talk about how these things are put together. And but it's also this kind of thing where, in a way, it doesn't necessarily sometimes matter anymore. It might have mattered when it was actually happening a few years back, when people were, and a lot of people were kind of pushing digital fabrication. But I think we're kind of now in this era of kind of post fabrication as well, where we know all the tools, we know how to make it, and at this point it's more about, is it ADA, right? Is it something we can actually put in a place? Can we convince the public of it? It doesn't, for me, the question is not anymore how to build it, because we've done it now so many times that it becomes something that's not important for me to talk anymore. But I hear you, because these things, and I said earlier, this thing, the router was running for 3 months straight, right? So the CNC machine was 3 months straight. We had to write really complex Grasshopper scripts to make this happen. There's a whole team of like 10 people putting this thing together over a couple of months. The logistics to build something at an airport is absolutely crazy. The permits you require, the kind of, the hands you need to shake, the favors you need to give to people, because we actually had to install this while the building was still under construction. And these things are a mess. I mean, if you don't have patience, it's very difficult to actually pull these things off. Particularly in this case, where you have different contractors coming in. Someone was in charge of the floor, somebody's in charge of the playscapes, somebody's in charge of the ceiling. Then there's a light person, even somebody to paint the wall. Everybody has to get background checked because we're at the airport, right? So, just this project, I could talk for almost 2 hours just about how to make this actually work. The kind of processes, or this thing in Denver, in Eugene. I mean, this was a very complex project to pull off as well, because the space is so difficult. Like the scaffolding that we had to build for this was really strange. I mean, the scaffolding was almost more interesting than the piece itself, right? Because how do you get there, right? How do you get there? What do you install first? Because this thing is made out of 600 pieces, right? So where do you start? So this all has to be kind of simulated and run in the computer. And that, of course, is a story by itself. But since we've done this now a few times, this is actually one of 4 that are very similar. I showed 2, but there's 2 others. It's not really our interest anymore. It's more about what does it produce now, what's the kind of effect that it does, and what does it in the larger kind of context for our work. Yeah.
It's funny because, and I have to put this a little bit into perspective. We know each other from like 17 years ago, I would say. Not that we were totally close, but we always crossed paths.
Yeah.
Like you went to the Bartlett after me, I think. I guess so. Yeah.
Yeah.
And then we met in London again, and you were at Foster's and then at Future Systems. So I think that's really where you became the architect who pays an interest in these things. And a lot of the work you were doing 10, 15 years ago was research. It was just paper architecture at the time.
Yeah.
Like funky models, and there was no fabrication. There were no widely distributed CNC routers, laser cutters. So you were really pioneer. And I think for me, it's interesting to see. I always admired your career, that you were able to get these commissions and actually build these sculptures, pieces. And it's really interesting what Dora was saying at the beginning when you talked about the future. And I look at this and I see how sophisticated the piece is and how unsophisticated the handrail is, or the window frame. It's like really conservative construction. There's a certain dichotomy. I almost want to see these pieces in galleries rather than in this realm. And that's interesting too, in a way, that you don't give a damn and you just do what you do and you just do it. And I think that it becomes really interesting when now that you're established as this public art fabrication, public art realm specialist, I don't know how you could call that, but and then looking at the work that becomes architectural again, because you are an architect and you're coming back to architecture now and you're building a bridge, and the bridge has like properties that are relating to the human body, and all this stuff goes away from sculpture, and what you learn from the sculptures becomes now architecture. And I think we see the same thing with the very many. We see the same thing with Achim Menges, and there's like these figures that started as pioneers of digital fabrication, and now digital fabrication is so ubiquitous that it's not special anymore. Now it's coming back to the actual, what does it actually do? How do you place it into a discourse? How does it fit into things that are just daily use, like a bridge, right? So where does this come in? And you're still pioneering to a certain degree. If I hear you have the router running for 30 days straight or something, right?
3 months.
For 3 months straight, that's crazy, yeah. But at the same time, that's, and we always have this talk in studio where we say we're still in modernism, we're still using industrial parts and assembling them to build buildings, and only if the construction industry would become robotic or fabricated, then we can actually evolve the architecture to something beyond modernism, beyond the assembly of industrial parts. And I think you're among the people who do that as pioneers in little projects, sculpture that's starting to grow, and that's really exciting to see, I have to say.
Yeah, I mean, usually there's not a single piece that's identical in anything I do. And that's really, when it comes to this kind of idea of the gradient, there's nothing in gradients that's identical either. I mean, in this piece, every component is everything has a number, right? Everything has its own kind of curvature. Like, for instance, these holes you see here, they're for two reasons. A, to reduce weight, right? So we needed to get weight out, so we cut into it. But also because these things are actually rolled on a sheet metal roller, because they need this kind of pre-curvature to it. And those holes are giving us orientation of how to roll it. So there's, but that's not architectural, that's more the logic of the fabrication. But what it does now, it produces kind of really interesting shadows. And also what it does, it actually becomes now an algorithmic code that the students at that math department have to calculate in their first semester, which was really interesting to us because, the faculty was interested in this thing, and that's what I wanted in the first place, because it's digitally designed and it has, it's scripted and these things. So they're like, well, let's take this piece and also introduce it to students as a problem. But this is the aftermath. This is not something that we wanted to do in the beginning. This happens then once it's there as well.
Are there any more questions from?
Thanks for sharing your projects. It was very interesting to see all the different types of work. It seems to me that the nature of a gradient is really a continuous object. But when you fabricate it, you have to go through the process of pixelating it or unitizing it or panelizing it, making it discrete. And when you do that, you have to naturally pick a resolution. What resolution is best may be heavily influenced by the fabrication process. But I'm wondering, through your process, through your experience, have you thought about, is there something inherent in the gradient that helps you determine what that resolution could be or ought to be or should be?
Yeah, I mean, that's a really good question, actually, because we face this pretty much in every project, the resolution of it. I would love to go as high res as possible. However, the problem then is you have more components, more parts, hence more time, more material, more things to paint, and so on. So at some point it becomes an economic question. right? It becomes a time question. So you have to find a kind of balance of getting a resolution that is compliant with what you can achieve and afford. We have now, I think, a pretty good understanding of what's possible in terms of budgets, what things will cost, what it will cost to bring a team of 5-6 people to a different state and have them stay in a hotel for a week and feed them and host them and actually have them install, for instance. We know what it takes to package 2,000 pieces. We know what it takes to paint 10,000 pieces with 6 colors or 7 colors. It's a big difference in terms of cost, but also in terms of time. So the resolution really is dependent on cost at the end of the day, because we can calculate it. We can make it as high res as we wanted to, but then it would just take longer, cost more, and these things. I think there's a few things that you can start to optimize, and visually you wouldn't see it. I think there's one fantastic project by Rob Lay, for instance. He did a parking garage application in Indiana, and I think he only used he used folded metal, but he probably had 20,000 pieces, right? But he only used 3 break angles, or 4 maybe, and there's no way you realize it's only that few, right? Because just with 2 or 3 or 4 angle breaks, that variation of breaking, you can still produce a mass amount of difference. So that was super smart. And actually, the break only has to be set in an angle, and you just do one after the other. The projects in the beginning of the show, they have all custom angles, which is really tough because you always have to readjust the break. And that just takes time and effort and basically costs money. So there's an immediate connection between the resolution. I think that's a really good question, between resolution and economics, for sure.
Thanks, Volkan. As you know, I really appreciate your work, and it's great to hear you talk about it as well. I guess I have a question for you about the title itself, In the Pursuit of Novel Forms, or Novel Form. And maybe the question arises a little bit from the question also that you just answered, which for me has to do with seamlessness. Mm-hmm. And maybe it's funny because when we get to volume, actually we see more seams. We see less of the rendering realized as physical thing. And now we start seeing the rivets but in pixel and pattern, we really see no seams. And I wonder about this topic of the pursuit of novelty and how you start to qualify novelty. Is it about the rendering becoming, which also you don't show renderings, which of course it's built work, but I love the contrast between the drawings and the images. So if I'm thinking about the pursuit of novelty, one question could be, how do you start to qualify that pursuit? Meaning what are the terms by which we would evaluate whether or not something is novel to begin with? And then if we agree that it is novel, whether it's about a fabrication technique or the rendering realized is now a seamless thing, how do we evaluate those effects? And part of it is interesting because you talk a lot in the beginning about typology, mm-hmm. and there's a sort of loose incorporation of history, if only to immediately push it away. So I guess it's a question about novelty. How do we evaluate novelty? Do we understand it as a procedural thing? Is it about fabrication? Is it about the atmospheric effects? Or is it more about an architectural discourse that is reauthoring history, even though we're not maybe privy to all of it in the talk?
Yeah, no, it's a very good question, and as I mentioned earlier, it's also a seminar I'm running with my students, and we have the same. I'm asking the same question: how do you actually evaluate if something is novel or not? If something has those qualities? So what we started doing is create these matrices of parameters that we want to achieve. We want it to be X, Y, Z, for instance, right? Because otherwise you're kind of shooting in the air, then it's very kind of subjective about what is novel, what's not. But for once, I think if we can hit those things on your list that you wanted to achieve, I think that's already a pretty good start. But for me, kind of novelty or in pursuit of novel form is really about looking at typology, right? And trying to see if there is any way to create with these techniques or other techniques new typologies. Which means, can we go away maybe from the simple atrium? Can it be something other than just an atrium? Now you get like super atriums and so on, which is, I think, a new type that just was introduced just recently, a few decades ago. Is a plinth still a plinth? When does it change to something else? There's many peers that work on roofs. I mean, you also have your research on certain kind of architectural types that you're trying to reinvent in a way or reconfigure. And in a way, I think that's what I'm, hoping that it would do at the end of the day. That it would create a kind of a new type, something that's maybe different from, some of the types I had shown in that kind of matrix. It's not always possible, right? But for instance, with this first project I showed, where it starts to make the corner disappear, that's something that I was quite happy with because. How do you make a corner soft, right? Like that's interesting as a kind of problem. And that's something I hope we achieved with that project. Not all of them have that quality at the end of the day, but if you have these if you have a small matrix of what you want to achieve, that's, I would say, a first start to answer the question. But yeah, it's not easy. And it will not always succeed. Not every project will hit that mark for sure. And my students, for instance, at the moment are looking at a lot of car crashes, right, to create novel form. But car crashes is not something new, in the discipline. Like, it's been done in art, it's been done in movies, it's been done in novels. It's been around for a long time, But, is it possible to introduce a car crash as a novelty, as architecture, right? So even though it might not be possible to create something novel, it forces you to look outside the kind of known boundaries. It forces you to look for other things that might influence the work. And I think that's something that just helps architecture to just grow and expand. Yeah. I don't know if that answers the question, but...
Okay, thank you. It's a nice closing statement, I think. Thank you.
All right, thank you.